everybody! We're gonna show you how to use configurations on OTA Drive. Let's create a new project. Pick a name and choose the board model. It seems okay. Let's make a simple blinker as we used to. It works well. First of all, we should implement the OTA Drive library to our program. We should find and add the library to our project first. Before we continue, we should define our project in the OTA Drive panel. Pick a name for it. Get the secret API key here. Come back to our Blinker program. First of all, we should set our product API key and firmware version to the library. Now we should start to connect to the Wi-Fi network. Then we should do some stuff to get new firmware from OTA Drive and sync our device configuration with it. I call my sync function in any loop cycle. We use a static variable as a counter or timer in order to increase the interval between each sync operation with the server. First, check network connectivity is okay. We call this method to get new firmware for the device if exists. Then I ask the server for the configurations by calling this method. Let's print it and see what happens here. Let's check the monitor console. As you can see here, the device gets a 404 error because it's not accepted in OTA Drive yet. So we should verify the device on the OTA Drive. It's done. Now you can see a new error because no configuration was defined for the device. Let's make one. Pick a name. Then you can enter any parameters, depending on your device features, in JSON format. I start with Wi-Fi credentials and blinking timers. Save it. Now we should assign this configuration to the group of the device. As you can see, the configuration is available here to select. Save it. Now you can see the device is getting our parameters from the server. To decode JSON format, install Arduino JSON library then included in our program. Declare a JSON object with 250 characters capacity. Decode the JSON string we've gotten from the server. We should stop operation if JSON is invalid or there is any problem in decoding. Let's print decoded parameters and see the result. Just, for example, I'm gonna print a string and an integer parameter. Let me check the correct spell of this parameter again. Now it seems to be okay. See the results here. As you can see, both parameters has been decoded perfectly. I'm going to define a data structure to store all of the device configurations in it. We have Wi-Fi credentials and blinking timings to define here. Then I declare an instance of the struct. Now we should initialize the configs object at the startup. Then we should use our config object anywhere, instead of constant values. Now, I'm gonna update the configuration values from the server values. Let's check the result. I'm gonna change the blink timings parameters and see what happens. It is not updated yet. Now the new timings applied. I'll do it again with other values. It's updated again. To save our configurations into EEPROM memory, we have to ensure the stored data is correct. I'm gonna use a sign variable to make sure the data is saved by me before. Each time I read the data from EEPROM, I'll check this variable with my constant sign value. If it wasn't equal to my sign, I'll load default values into the config object. By the way, I'll save the default values and the sign value into the EEPROM too. Also, after each synchronization, I'll save the configs into the EEPROM. I've missed a command in order to save data into EEPROM. As you can see here, the sign value has been checked and it is valid. Now we can be sure that our configurations sync automatically from the server and it saves into EEPROM in a safe way.